I'm here in Cambridge at one of our innovation hubs at Philips, and I've had a chance to meet with our designers and our scientists, our engineers, all collaborating to innovate the future of healthcare. Now, I had a chance to meet a really brainy guy by the name of Mike. Mike has been with Philips for over 3 decades, and he's innovating the future of cardiac ultrasound. Have a listen. What brought you into Philips?
Well, what brought me into Philips is I first started at Hewlett-Packard Medical back in the 80s, working as an entry-level transducer engineer. From the minute I started here, there was always a full complement of people who understood medicine, whether it's chief medical officers, for example, in your position, or if it's people who've worked in cardiovascular X-ray. The Cambridge campus is just that too. We have every single piece you could imagine. There's engineers of all stripes and all disciplines. There's clinical specialists who have done their entire career in sonography. There's business and marketing people who really understand medicine very well. There's integrators and optimizers who've dedicated their lives to make the perfect image. But the best part is that right across the street and virtually around the world, we can collaborate with some of the best physicians and the best institutions in the world to really bring these solutions into reality clinically. I'm a principal development engineer. I've been at Philips for more than 30 years, developing new and innovative transducers from the beginning, which was initially phased array ultrasound, to what is now what we call X matrix technology. It is matrix technology that allows real-time 3D imaging of the heart using ultrasound.
That's a mouthful. I call it a mini TEE probe. In fact, we have one right here, and I know you were instrumental in its development. So can you tell me a bit about this new mini TEE probe?
Sure. Our new X11-4t, or mini T as you call it, has all the functionality of our current X82T adult transducer, which means it functions in all the 2D modes plus live 3D and all the multi-plane imaging involved. The new matrix technology allows us to take a full volume of the heart. Within that volume, we can either look at the entire volume, or we can slice image planes any way we want to inside the volume. We can also look at all those volumes, either the volume or all the multi-planes simultaneously. That's the real-time aspect of it. This allows the physician to have much more confidence in terms of assessing the heart, in terms of diagnostics, in guiding procedures, in guiding devices into their positions. As we know, the heart is not a one-dimensional and two-dimensional thing, it's three-dimensional, and it's moving back and forth in a way that produces flow through the heart. All those together are much better visualized when you have a 3D volume to look at in associated 2D planes that you decide to cut through. The difference with our new T-probe is that it's much smaller than the traditional adult size.
I mean, that's one of the things that excites me the most about this. I've seen traditional transesophageal echo TEE probes. Presumably, we can now treat small kids, 5 kilograms or bigger, all the way up to 90-year-olds, and people even with esophageal strictures, stenoses, people that couldn't be treated before because they needed a big probe. We can now miniaturize this, which I guess should increase access to care.
That's the thing that excites me the most about it, and the reason why I had the passion behind this is to get more people to be able to have accessible treatments, whether it's for their structural heart disease problems or, as you mentioned, particularly pediatrics. Pediatrics have the challenge of congenital heart defects. From the minute we introduced our adult probe, the pediatric community was really looking for a smaller probe to access these small patients who have congenital heart defects. And the reason is to gain more confidence for diagnosis. There's very complicated 3D structure that is not normal, as well as the interventional part of it. When you get in and start doing interventions on these complicated structures, having a small 3D T-probe for pediatrics really adds confidence to their procedures.
Mike, thanks for the education. Thanks for the innovation in 3 decades at Philips. I can't wait to come back to see you again and see what else you have cooking.
And now, you're in the know.